Hello everyone. So in this lecture we will go through the machine language. So in this topic we will study about the no looping and looping concept. This is the most important concept in system programming. So how by using the machine language or the assembly language we can write the no looping and looping programs. So here no looping. Here there is an example where in a memory location a number 49 is there and the number 49 is added to the next 10 numbers. Okay, and after adding, suppose a number 100 is there, then 49 is added to 100 and 149 is stored in that location. So serially we have to add the numbers from that location till the 10th location. Okay, so that is the program to write. So here we can see write a program that will add the number 49 to the contents of 10 adjacent full words in memory under the assumptions. So 5 assumptions are there. In the first assumptions, the 10 numbers are contiguously stored in the memory from the memory location 952. Okay, after this we will see there is a image is there, a figure is there. We can see the location 952 there. Okay, the program is in the core memory. Okay, all the programs are in the core memory. The number 49 is a full word. Full word means 32-bit at absolute location 948. So number 49 is stored in 948 location. Register 1 contains a 48. Each instruction is a 32-bit full word starting from absolute address 48 and relative address 0. Okay, so this is the image you can see. Okay, here you see here that 49 is there and data 1, data 2, data 3, data 4, data 5, data 6, data 7, data 8 and data 9 and data 10. These are contiguously stored in this memory. So our main objective is to add this 49 with data 1 and with the data 1 and store that that output in this location 904. Then again we add the 49 with data 2 and the result is stored in 908. This process continues until data 10. Okay, so we have to write this program in a machine language. Machine language, here we are applying assembly language which we can understand by reading the program. Okay, here you see absolute location is there and relative location is there. Then what is absolute location? Absolute locations means that position where the program is actually reside. Okay, the actual position of a program or the instruction is called absolute location, and relative location is a logical address system. Okay, so basically we understand the problem to add 49 with each number and store the calculated output in that location. So how to write it using a no looping format using the assembly language? So here you see a program is there. Okay, here absolute addresses are there, relative addresses are there, hexadecimal is there, instructions are there, comments are there. So first of all, suppose you see the relative address 0 and the hexadecimal address is this 58201388. It is represented like this. So this is the first step we have to do for no looping. We know that no looping means suppose we want to continue or process same steps, then we have to write all these steps, but in looping we just call that step again and again. Okay, but here we have to write this 10 steps. So this is the concept of no looping. Okay, here you see we have written load L 2,904. Okay, 0,1 means the value in 904 is loaded to the register 2. That means that. Okay, then add is there. That means the value in 900 means 49 is there, it is loaded to register 2. 2 by adding it with what? By adding it with the previous number, okay, the data in that location, okay. Because 904 data 1 is in 904, so it is loaded in register 2. Now we are loading that same 49 to the same register, so both the numbers are added there, okay. So add, okay, and the final result is stored in 904, okay, 904 location. So load, add, store for a single addition. So for data 2, same process continues, load, add, store, load, add, store, like that we have to continue all these steps till data 10, okay. So now the no looping code is complete. So here we can see the steps for no looping, okay. You can go through the Donovan book, and you can easily understand the steps of no looping. See, one concept is there in no looping. If 300 data is processed, then 300 plus 3 instructions are to be processed. Here 3 means load, add, store, okay. Each instructions take 4 bytes, so 900 cross 4 is equal to 36,000 bytes it will take. So it is too long and it will take so much memory, okay. So we have to reduce the instructions and it may overlay the data, okay. That's why we have to reduce the instructions by writing 3 simple statements and then repeating that same steps. So for that we are using the concept of looping. So here looping have some assumptions here, okay. So here you can see this is the program written in assembly language, where you can see SR 4,4 instructions, SR 4,4. This means that we have to clear register 4 first, then load the data, then add the data, then store the data, as same as that. But here one thing you see, this SR instruction takes 2 bytes, load instruction takes 4 bytes, add instruction takes 4 bytes, store instruction takes 4 bytes, and then after the 3 instruction we have to write another instruction that add 4,896 0,1, means add 4 to index register. This means that after the 3 steps we have to go to from data 1 to data 2. That's why it is increasing by how many bytes? 4 bytes. So that's why we are adding 4 to the index register, okay. So this branch back to relative location 2 9 times. So this will continue 9 times. So this is the algorithm what we have used for looping. You can study this. Then here in this lecture we have studied about the machine language.